In this video, we will discuss about the structure of atom for grade 9 students. We will learn about the development of atomic model, and concept like isotopes, electronic configuration, isotopes, electronic configuration, electronic configuration. The composition of matter is always a mystery for scientists. Matter. The composition of matter is always a mystery for scientists. Many philosophers and scientists worked for centuries to solve this mystery. A Greek philosopher, Democritus, Democritus, in 370 to 460 BC, for the first time suggested that all matter can be ultimately broken down into tiny particles. Matters can be broken down into tiny particles that cannot be further divided. That cannot be further divided. So this is the uh, philosophy of Greek philosopher Democritus. For the first time, that he suggested that all matter can be ultimately broken down into tiny particles that cannot be further divided. These particles were named as atoms. These particles were named atoms, which were derived from the Greek word atomos. So the word atom is derived from the Greek word atomos, which means inseparable. This means inseparable. So this is about the uh, theories experiment related to atomic structure. Now we will discuss about theories and experiments related to theories and experiments. Theories and experiments related to atomic structure. So we will see that although the word atom was first used in 400 BC, however, no further work was used till 19th century. No further work was done till 19th century. Then it was John Dalton, which was an English school teacher, who, after a series of experiments, concluded that all metals must be composed of tiny particles. All metal must be composed of tiny particles, which are like solid balls and cannot be further divided. These tiny particles are like solid balls, which cannot be further divided. This is uh, the concept of John Dalton. He called them atoms. John Dalton calls them tiny particles atoms. He presented his theory under the title "A New System of Chemical Philosophy." New system of chemical philosophy. The main postulates of Dalton theory in 1808 are as follows. Dalton theory means postulates of Dalton theory, which was presented in 1808. The first postulate is that matter is composed of very small particles called atoms. The second postulate is atom is an indivisible particle. Atom is indivisible particle. The fourth one, the fourth postulate of Dalton atomic theory is the third postulate uh, is that atom can neither be created nor destroyed. Neither atoms can neither be created nor destroyed. This is the third postulate. The fourth postulate is that atoms of particular element are identical in size. Atoms of particular element are identical in size, shape, mass, and also in other properties. Number five. The five postulate of Dalton atomic theory is that atoms of different elements are different in their properties. Atoms of different elements are different in their properties. Number six, atoms combine with each other in a small whole number ratio. Atoms combine in small whole number ratio. All chemical reactions are due to combination or separation of atoms. All chemical reactions are due to combination or separation of atoms. So all chemical reactions are due to combination or separation of atoms. So these are the seven postulates of John Dalton atomic theory. So next one is the Rutherford atomic model. Rutherford atomic model. Rutherford atomic model. In 1911, Rutherford performed an experiment in order to know the element of electrons and protons in an atom. Element about electrons and protons in atom was presented by Rutherford by an experiment in 1911. So Rutherford, first one is Rutherford experiment discovery of nucleus. Rutherford performed an experiment to determine the internal structure of an atom in 1911. For this purpose, he used a thin gold file in gold file, such as this one. Use the thin gold file. The gold file was surrounded by a photographic plate, like this one. This is a photographic plate, which in which the gold file, this gold file is surrounded to detect the particles emitting from the radiation source. This is the radiation source. Polonium was used as a radiation. So he bombarded this uh, gold plate with the alpha particles, so radiation. He bombarded this gold file with approximately more particles, 20,000 alpha particles, from a radiative source. So this is a polonium metal. He observed that about out of 20,000, 19,990 of the alpha particles passed through the gold file without any change in direction. So you say that more alpha particles were passed through this gold file without any change in direction. It showed that most of the volume occupied by the atom is empty. So when this alpha particle passed through this gold file, it means that most space of the atom is empty. Some alpha particle were deflected through small angle. In this particle, some alpha particle were deflected through small angle, like this, small angle, like this. Only few were bounced back at a random way. Some were bounced back and bombarded. Some were bounced back at a random way. Rutherford concluded from this that atom contain a positive portions nucleus. So from this he concluded that uh, atom is uh, composed of. He concluded uh, that atom contain a positive portion. This is an atom. This is say positive portions. So it's a nucleus. This is the nucleus. This is an atom. Atom consists of positive portions called nucleus in the center of the atom. This is the nucleus, which is in the center of the atom. So particle passed near this nucleus were repelled like this, like this, like this. You can say the particle passed near this is repelled because alpha particle also have positively charged particles, a positive charge and similar charge particle. So we can say that this nucleus, it has a proton contains positive charge, neutron is charged. So an alpha particle having positive charge passes near the nucleus, they bend, they change the direction, because opposite charges, we can say that positive charges repel each other. So for these reasons, some alpha particle were deflected when they passed near the nucleus. So this is the way Rutherford discovered nucleus. If in the same way, if alpha particle passed very closely to the nucleus, they deflected to large angles. See this is an atom. This is I can say that this is the atom, this is nucleus. If the alpha particle passed near, they were deflected at small angles, at large angles. If they pass near to the nucleus, and this is the same way, it's like this. Similarly, if they don't pass close to the nucleus, if they pass don't close to the nucleus, they get deflected to very small angles or don't get deflected. This is they pass far from the nucleus, they deflect a small angle or don't get deflected because they are farthest from the nucleus. On the basis of his conclusion drawn from this experiment, Rutherford proposed a new model of an atom called planetary model. Rutherford proposed a new model of atom called planetary model, which is similar to the solar system. And which put all the protons in the nucleus and the electrons around the nucleus, like planets around the sun. Planets around sun. So you can say that proton inside the nucleus and electron outside the nucleus. Around the nucleus. It's electron around the nucleus, proton inside the nucleus. So this is the Rutherford atomic model. So next, main points of the Rutherford atomic model. Main points of Rutherford model. What are the main postulates of Rutherford atomic model? It will consist of positively charged certain portions. He says that this atom is contains center positively portions called nucleus. This is nucleus. This is positive, having positive charge. Electrons are revolving around the nucleus. This is electrons, and this is the nucleus. You can say that electrons are revolving around the nucleus, same way like this. These electrons which are revolving around the nucleus with very high speed, just like the planets around the sun. Electrons are revolving with high speed around the nucleus, just like planets which are revolving around the sun. The size of the nucleus is very small as compared to the size of the atom. The size of the nucleus in this nucleus is very small as compared to the size of the whole atom. And most of the volume occupied with the atom is empty. This atom is most volume. This is empty. This is empty volume, and an atom. So atom is neutral. As one thing is to be noted that if you consider a football ground, this is a football ground. We have a football in the center, placed in the center of a ground. We will say that the football ground is just like an atom, but the ball placed in the center of a football ground is just like a nucleus. So also, atom is neutral. Atom is neutral. Why? Because the number of electrons is numerically equal to the number of protons. Number of electrons is equal to number of protons. So when this number of protons and electrons are equal, we can say that atom is numerically the number of protons and electrons equal, so atom is neutral. Nucleus is responsible for the mass energy of an atom. This is the nucleus, and this is responsible for the mass and energy of atom. Mass and energy of atom. So the nucleus is responsible for the mass and energy. You can say that the nucleus mass and energy is due to the presence of nucleus inside the atom. So next one is the atomic number and mass number. We can say the atomic number, which is represented by Z. This is atomic number of an element, and atomic number is basically the number of protons or number of electrons in the atom. So you can say that atomic number is represented by Z. The mass number is the in an atom is the number of protons and neutrons. This is the mass number of protons. We can say the number of electrons is the Z, the atomic number. This is the mass number of protons and electrons, both are called mass number. The chemistry of an element is controlled by Z. The chemistry of an element is controlled by Z, which is proton or electrons. How is it controlled by Z is that nuclei with the same Z will have similar chemical behavior. Nuclei with same Z have same chemical behavior. So we can say that nuclei of an atom having same number of protons or electrons, you can say the same atomic number will have similar chemical behavior. Nucleus also contain nucleus in atom also contain neutrons. And is the neutron numbers. Neutrons are uncharged particle with masses approximately equal to the mass of a proton. Mass of proton will be almost equal to that of electron. So each proton has a positive charge equal to that of electron. The overall charge of a nucleus is Z plus electronic charge units. Most of the atom is empty space in which electrons around the nucleus. Electrons are small negative charge particle with a charge of -1. Electrons have -1 charge and mass of 1 by 1840 of proton mass. So we can say that electron is 1840 times smaller than protons. We can say that electron is 1840 times smaller than protons. The negative charge electrons are bound by electrostatic Coulombic attraction to the positively charged nucleus. So this you can say the electrons and the nucleus having protons. So these electrons and protons are bounded to each other by Coulombic. This is a Coulombic force. The Coulombic force or electrostatic force. Electrostatic force due to which these protons and electrons are. This is bonded in the atom. In a neutral atom, the number of electrons is in the atom is equal to the so defects in Rutherford atomic model. The Rutherford atomic model of an atom resembles our solar system. There are the following defects. First one is we can say that Rutherford atomic model is based on the law of motion and gravitation. It is based on law of motion and gravitation, which are applicable to neutral bodies, and not uncharged bodies. So this is the first defect of the atomic model. Second one is if electrons radiate energy continuously, then it will fall finally to the nucleus, but actually it does not happen. So this is the second effect of the Rutherford atomic model. We said that electrons continuously emit radiations. So if this is the case, then this electron will finally fall into the nucleus, but it doesn't. In other words, we can say that electrons radiate energy continuously. If this is the case, then continuous spectrum will be obtained, but actually line spectrum is obtained. It does not provide an explanation. It doesn't provide an explanation about the chemical properties of the elements. This is the other defect of the Rutherford atomic model. With the fourth one, we said that electrons are charged bodies revolving around the nucleus. This is the case. Electrons are charged bodies revolving around the nucleus. If this is the case, then electron will eventually fall into the nucleus, but it doesn't happen. So this is all about the Rutherford atomic model.